Hey everyone, we're here to report about Chapter 16, which is about fire and overheat protection. But before that, let us introduce the group that will be discussing this chapter. I'm ADRYEL FLAUTA. This is my members, GABRIEL BAUTISTA, YNDL NAVARRA, and MJ CRUZ. Fire on board an aircraft is a very serious hazard, and the best way to protect the aircraft from fire is to prevent it. Fire protection on the aircraft means by detecting and extinguishing the fire. Fire protection theory is a branch of engineering in its own right, and the objective of this report is to provide the reader or viewer with sufficient information to understand how this theory is applied through the electrical aircraft system. The chapter focuses on the equipment and system used to detect fire and smoke together, and with the means of delivering the fire extinguishing agent. Overview. Now, fire protection system and equipment are divided into specific area of the aircraft. One is engines and APU, the second is cargo bay, and the last one is passenger cabin. Now, fire protection technologies used on an aircraft depends on the areas and the specified fire risk. And also one thing to note that overheating may not be as severe as a fire, but overheats can weaken a structure and damage the components over time. Now, up until the 1990s, there were two agents used extensively in the aircraft, and those were, now I am not gonna pronounce it to you, but let's just call it Halon 1211. The second agent used is, I am not gonna pronounce it to you, but let's call it Halon 1301 instead. Halons were very effective in their job. However, as of now, they were banned from being manufactured due to them not being eco-friendly. Although they still allow the use of it, but only through recycling. Now, due to halons being banned, we are offered with three alternatives: water, dry powder, and vaporizing liquid. So, another topic is combustion, which can be defined as a rapid and complex chemical reaction in which light and heat are evolved. Now, there are three factors that are required to initiate and sustain combustion. Fuel, in which includes solid, liquid, or gases. Oxygen, which is usually available from the air, unless you're from Mars. And heat. Now, the type of fire detector and extinguisher is dependent on which kind of fuel is likely to combust. Now, there are three ways to detect a fire, such as thermal sensors, optical sensors, or smoke detectors. Now, extinguishing them is another type of topic, such as limiting or eliminating the fuel, limiting or eliminating the oxygen, or reducing the temperature of fire, or even interfering with the chemical reaction. In the next figure that I will show you is the fire that are categorized by the type of fuel that are combust. Class A is either solid or organic, which can be extinguished with water or vaporizing gas. Class B are flammable liquids. Class E is electrical equipment, and Class F is cooking fat and oil, which can be both extinguished by dry powder, carbon dioxide, or vaporizing liquids. Now, Class C is a flammable gases in which can be extinguished, same as Class B. Class D metals can only be extinguished by the use of dry powder. Now, the primary sources of risk or fuel in an aircraft applications are: Class B is in an engine and APU, while cabin, flight compartment, and cargo bay are both classified as Class A. Now, each of the fire extinguishing agent has different attributes. Water reduces the heat in a fire, and usually, if we mix water with an additive, glycol, it enables the water to be used in sub-zero temperatures. While vaporizing liquids reduces heat, but their significant contribution is to interfere with the chemical reaction of the fire. Carbon dioxides and dry powder both reduces the fuel temperature and reduces the oxygen level.
Engine or APU fire detection. Engine APU fire detectors are designed to various standards. They are needed when other systems, procedures, and safety features have failed to prevent a hazardous situation developing. In terms of fire protection, the engines and auxiliary power unit can be considered as having the same requirements. Fire detection within an aircraft engine can be achieved by thermal and/or optical methods. First is thermal fire detectors. It sends heat energy that is radiated from the fire. They can be either put unit detectors or sometimes referred to as point or spot detectors. Next is optical fire detectors. This is based on sensing ultraviolet or infrared energy. Whatever the sensor technology, the engine is fitted with sensors in positions that provide coverage of all areas where a fire could start. These positions are determined mainly from experience with an engine type. When a fire is detected, the warning system activates an alarm bell and illuminates red warning lights in the flight compartment. The fire warning also illuminates a master warning light. Thermal fire detection. There are various techniques used to detect fire and overheat by including unit, linear detectors, and optical sensors. First is unit fire detectors. This type of detector can be used in engine fire detection system. Alternatively, it can be used in the bleed air overheat detection system. Linear fire detectors. Three types of linear fire detectors are used on aircraft. These are based on averaging or discrete detectors. Third is the optical fire detection. Optical sensors sense the light emitted from a flame in much the same way that a person recognizes fires. Our brains can distinguish between the light energy from a fire and the light energy from another source. The optical fire detector or sensor also has to be able to make this distinction. As with any fire detector, whether thermal or optical, the response time of the detector depends on the first, size of the fire, second, rate of propagation, third, type of fuel burning, and fourth, distance from the detector. The average response time of aircraft engine fire detectors is less than 5 seconds. This is in response to a standard 1100 degrees Celsius, 6-inch diameter flame.
Now, that was an amazing reading session from my groupmate YNDL NAVARRA. Now, the next topic is cargo bay or baggage area. Now, this area is most likely the source of fire in the aircraft due to its organic materials. In this area, they use as a smoke detector. Now, there are two basic principles of a smoke detector, which is ionization and photoelectric. Now, ionization is the type of smoke detector that can detect particles of smoke that are too small to be visible. Now, on the other hand, photoelectric smoke detectors measure the light or reflection within a chamber. Now, there is a classification process approach on a fire protection strategy for cargo bay areas. It is classified from A through E. Now, Class A is present of a fire that would be easily discovered and easily accessible in flight. Class B is a combination of cargo and passengers on the same deck. Class C is typically the same as Class B, but compartment may be below the main deck of the aircraft. Now, Class E are compartments on aircraft used only for the carriage of cargo and do not carry passengers. Now, the last is Class D. Now, Class D is the area where it was designed to use oxygen starvation to contain fire. However, this kind of method were banned and phased out due to incidents involved uncontained fires. Class D usually goes to now a Class C cargo instead.
An overview, Chapter 6.4 Fire Extinguishing. Extinguishers are used in the engines, APUs, cargo bay, cabin, and flight compartment. The type of fire extinguishing agent used on an aircraft and the method of activating the extinguisher depends on its applications. The type of agent used depends primarily on the type of fire being addressed. Other factors to be considered include toxicity and storage temperature. Some agents, such as water and dry powder, are expelled from the container by high-pressure gas. Some agents, such as carbon, are gaseous at room temperature and can be stored as liquid under pressure.
We'll be discussing the cabin and flight compartment. Handheld fire extinguishers are portable and operated by first removing a safety pin and then squeezing the handle. Waste bins located in the aircraft cabin washrooms are vulnerable from fire started by passengers disposing of cigarettes. This threat is largely eliminated by no-smoking flights. So, engine or APU and cargo bay fire extinguishers are secured to the aircraft or engine structure outside of their respective fire zones. Agent is directed into the fire zone via a pipe. So the last one is the cargo bay fire extinguishers. Such they are operated from a Control Panel Selector. This system features two fire extinguishers. The first bottle provides a high rate discharge to knock down the fire. The second provides a low rate discharge to prevent reignition.
Now, that was an amazing presentation from my group mates MJ CRUZ and GABRIEL Bautista. The reading session was so amazing and knowledgeable. I hope that this video was able to help you understand the fire protection on an aircraft system. Thank you for watching.